Okay, had to share some of my 80s music with you. This is one of my favorite days of calculus today. So I thought I'd share a little music, pump you up a little bit. We're starting section 3-4, and we will be spending a couple days here. And we are going to do derivatives again, but this time, instead of doing derivative right at a single x value, we're going to find the derivative function. So I'm going to take it back, review what a derivative is all about again. So if you have a function, and we want the derivative at a given x value, we know that we are looking for the slope of the tangent line here. And we can use limits to help us get that slope, because if we move a horizontal distance away from x, some horizontal distance, this new x value would be x plus h, and that would also have a point on the function. So this one would be f of x. This other one would be f of x plus h. And if I could slide this one in closer to the original x value, in other words, make h approach 0, get this distance to approach 0 so that it's getting very, very, very close to x, whatever the slope of that line is, whatever those slopes appear to be approaching as I slide in, will be the derivative. So we want to get an equation that gives us the slope of that secant line there, which is the change in y over change in x. So it's going to be, so the derivative equation will be the limit as h approaches 0, because I want to slide this x value in so it's very, very close to that, and see what happens to all of the slopes as I get closer, see what value they're approaching. So the change in y's would be f of x plus h minus the f of x. That's going to take the change here. That's going to give me the rise. That's the change in y over the change in x. Well, that's just the difference between these two x values here. So that's x plus h minus x. Well, the only simplifying you can do is right down here, your x's cancel each other out. So your derivative equation that you're going to be using today is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, lots of algebra today. That's probably why it's one of my favorite days. So we're just going to go through two of these because they're quite long and involved, but it's just algebra. So given that f of x equals 2x squared plus 3x minus 4, I want you to be able to find f prime of x. The other day we put a number in there. We found the derivative at a specific number. Now we're going to find the derivative equation. So the derivative equation is when we use this h definition here. So f prime of x is equal to the limit as h approaches 0 of, I need f of x plus h. That means you go back to the original function. Wherever you see an x, you substitute in x plus h. So 2, in place of x, I'm putting x plus h. Then I square that. Plus 3, in place of x, I'm putting in x plus h. Minus 4. So all of that is my f of x plus h then I have to subtract f of x. And f of x is this original quadratic. So with parentheses, because I'm subtracting, 2x squared plus 3x minus 4. Okay, all divided by h. Now what you have to do is expand all of this stuff and combine like terms in the top. So, we've got the limit as h approaches 0. I have to expand this binomial. I have to square it. I can do FOIL, or I'm going to go to the Pascal's triangle that we had and use that for expansion. And if you look, I know it's going to have 3 terms because I'm squaring. The multipliers are 1, 2, 1. So I'm going to go 2. The 1, 2, 1. I start with the first term, which is just an x. I go x squared. X to the first, nothing. Take the second term, start on the end, start with it squared. Then to the first, then nothing. Put some pluses in here. Now I'm going to take the time to distribute the 3. So plus 3x plus 3h minus 4. Now I'm going to distribute the negative here. So minus 2x squared minus 3x plus 4, all divided by h. And just to save the line, I'm going to distribute here to these 3 terms and put them up here. So I'll have 2x squared plus 4xh plus 2h squared. And then plus all this stuff I have here. So the limit as h approaches 0, simplifying, I've got 2x squared and a minus 2x squared. Those are gone. I've got a 4xh. Let's see, a plus 2h squared. I've got 3x and a minus 3x. Those are gone. I have a plus 3h. And then I've got a minus 4 and a plus 4. Those are gone. So after simplifying, I only have 3 terms left, all divided by h. If I substitute the 0 in, I got 0 times 4x, 0 squared, 3 times 0. I have 0 over 0. Remember, that tells me I've got a common factor. And my common factor is just an h. It's a greatest common factor for all 3 terms. So I'm going to take an h out of all 3. And when you take an h out, you're dividing it out. So I had 4xh, so I'm going to have 4x left. If I was to multiply back in, I'd have the 4xh. Taking an h off of here, I've got plus 2h. See how if I distribute back in, I get back the 2h squared. And here, if I had a 3 times h and I take out the h, and when you take it out, you're dividing it out. I've got a 3 left behind. What that does for me is allow me to cancel off the h's. So my limit as h approaches 0 becomes just the limit of 4x plus 2h plus 3. Now substituting the 0 in for the h, not the x, it's going in for the h. My derivative is 4x plus 2 times 0 plus 3 becomes 4x plus 3. That's my derivative equation. Now I could ask you questions like, well, what's the derivative at 4? What's the derivative at negative 6? What's the derivative at 10? And instead of having to use that C definition from the other section, I can now just plug these 3 values in. 4 times 4 plus 3 That's 16. 19 is the derivative, so the slope of the tangent line at 4 would be 19. For negative 6, 4 times negative 6 plus 3, negative 21. So the slope of the tangent line at negative 6 is negative 21. And I get 43. So instead of having to do 3 of the problems from that section 3.2, I just do one of these long ones, and then I can get the derivative at any spot I want. So you want to get good at all of this algebra in here. That's all we're going to be doing today, is practicing that formula. So let's try another one. Let's start with f of x equals 3x to the 4th plus x plus 1, and your goal is to find the derivative function of x. Okay? So f prime of x is the limit as h approaches 0 of, and I'm going to write the definition out, then we'll substitute in. It was f of x plus h minus f of x all over h. So the limit as h approaches 0. So f of x plus h, what that means is, go back to the function, wherever you see an x, you're going to substitute in x plus h. So I keep the 3. In place of x, put in x plus h. That's to the 4th power. Plus, now I just substitute in what x is. X is now x plus h. And then plus 1. Okay, all of that is the f of x plus h. I still have to go do minus f of x minus, remember the parentheses here, because there's usually more than one term, and there's 3 of them here, and you've got to subtract all parts of it. So it's 3x to the 4th plus x plus 1. All divided by h. It's this expansion here that's going to take you some time, and you're going to use that Pascal's triangle again. Remember, if you're going to the 4th power, it's the row that has 5 terms in it. So I don't have that table right here in front of me, so I'm going to crank it out real quick. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So it's the next row. 1. Add those together, you get 4, 6, 4, 1. So it's going to get quite long here. So we've got our 3, and then our 5 terms. 1, 2, 3, 4, 5. The multipliers are 1, 4, 6, 4, 1. Start with the x. X to the 4th. X cubed. X squared. X to the 1st. Now the h at the end, h to the 4th, h cubed, h squared, h. And then the rest of this I'm going to distribute to get rid of parentheses. So there's a positive in front of this one, so it's just plus x plus h, plus 1. Here I have to distribute the